Find the general solution of the differential equation. So we have a second order non-homogeneous differential equation, and we call the right hand side as just G. To solve this equation, we first consider the corresponding homogeneous. Just make right hand side 0. Y double prime plus 9y equals 0, and we find the solutions. To solve, we find the characteristic equation, which is r squared plus 9 equals 0. Solve for r, that's plus minus 3i. So cosine 3t and sine 3t are two solutions. Then we can write down the general solution of this homogeneous, which happens to be the complementary solution. Then yct will be just c1 y1, which is cosine 3t, plus c2 sine 3t, where c1 and c2 are arbitrary constants. Then the solution of this equation, the original equation, will be yc plus yp, a particular solution. Okay, then this is yc. Now a particular solution will be, then just replace c1 and c2 by new functions. u1 is a function of t, cosine 3t, plus u2 sine 3t, where u1 and u2 are found using these two formulas here. Okay, so to find u1, we need to find the Wronskian of two solutions, y1 and y2. So let's find that on side here. So the Wronskian of y1, which happens to be cosine 3t and sine 3t, that will be just a 2 by 2 determinant, cosine 3t sine 3t in the first row, and their derivatives in the second row. So that's negative 3 sine 3t. Here is 3 cosine 3t, and we multiply this minus this to determine this determinant. So cosine 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 square, so this is 3 cosine square 3t minus this way, and there is negative, that makes it plus 3 sine square t, sine square 3t, and we can factor 3 out. That leaves cosine square plus sine square, which is 1. So 3 times 1 is 3. So the Wronskian is 3. So this is a particular solution where this u1 is found by this formula here on the top. So that's negative g, that's the non-homogeneous part in the question, 2 secant square 3t, 2 secant square 3t times y2, and y2 is, look at here, y2 is sine 3t, all over Wronskian of y1 and y2, that we found 3 dt. Let's find this. 2/3 can be pulled outside, negative 2/3. Now we have secant square and sine. Okay, secant square and sine. We know the antiderivative of secant times tangent, like this. Secant tangent is the derivative of secant. Okay, so secant tangent, but there is no tangent. But look at secant square is secant times secant, and secant is reciprocal of cosine. So 1 secant is 1 over cosine, and sine over cosine is exactly tangent, so it matches. So let's do that. We pull 2/3 out. Secant square is in fact secant times secant. Another secant is 1 over cosine, and we have sine on the top, and sine over cosine is in fact tangent. So let me write here, sine over cosine is tangent. So let's not waste this step. This is pretty much tangent. Okay, and the derivative of secant is secant tangent. We have 3, so when we integrate we need to divide by that 3. So this is same as now negative 2/3. Antiderivative of secant tangent is just secant, but this 3 we divide by 3. When we differentiate we multiply by that 3, but in this case divide by 3, which is then negative 2/9 secant 3t. Okay, that's u1, and using the second formula just given on the top here, now we find u2. Okay, and u2 equals no negative g, that's the right hand side, 2 secant square 3t times y1 is here, by the way, that's cosine 3t, all over Wronskian, we found that 3 dt. Let's find this. 2/3 can be pulled outside. Now secant times cosine is 1, because secant and cosine are reciprocals. We have secant square, so 1 secant times cosine is 1, just 1 secant survives. So this is just only secant 3t, and this is 2/3, and we know the antiderivative of secant, that is just natural log of secant plus tangent, secant plus tangent. Like last time the angle is 3, so we need to divide by 3, so that's 1/3. Okay, which is in fact 2/9 natural log of secant 3t plus tangent 3t. Okay, so in this way, now let's go back and see. We found yp, particular solution. u1 and u2 are found here, and the sum of yc and yp gives the solution of the original ODE. Okay, hence the solution y is complementary solution yc plus yp. Okay, and where yc and yp are found above. Okay, final.